Hi, Chloe. Chloe, can you hear me? Chloe, are you there? Hello, Jingjie.
Hi.
Okay, good to see you. So, well, Chloe is supposed to be here, but she hasn't responded. Hold on, guys, give me a moment. Yep, okay, guys. I hope you're seeing the screen right now. Okay. Yep, this is what we did the last lesson. Anyone has any questions about it? Or what we've gone through in the last lesson? No. All fine. Well, first thing first, make sure you have your notebook around with you so that you can continue copying your stuff. Okay, so let's have a few things to be sure. Now, I want to be very clear for this particular chapter. I would say the good news. Let me just be a bit. Okay, there is likely to be just one single formula that you need to use. And I have covered that before. Right, sorry, give me a moment. So 没有灰色哦，这个啊，这样我看得到2月咯，不能这样来做啊。好了，OK OK，好，你是 OK，拜拜。Yep. Okay, like I say, there's only one particular formula to use, so I'll be very quick about this. Now, you should have written this down previously, so this is the one. For this chapter. However, if you go to the next few chapters, there could be other, obviously there will be other formulas. Now, Chloe, tell me what is capital I?
Current.
Okay, good. And what are the units for current, Chloe?
I don't know.
Okay, so yep, make sure you're very familiar with it because it's 100% coming out. No running away from it. So the units will be in amperes. It's written as a capital A. Right. As for Q, come Jingjie, what is Q?
Charge.
Units for charge, Jingjie.
C.
Okay, so well, it stands for coulomb. And make sure you write it as a capital C. As for small t, again, you should be familiar with this by now. It stands for time. Obviously, make sure you use the SI units of seconds. So this is the only formula that you will encounter in this particular chapter, right? So just to be sure, when do you use this formula? Now, as we said before, this chapter involves charges. Now, again, let's be very clear. Charges can be positive or negative. But the point is this, once your charges flow, they are not static, they are not stationary. Once they start moving, of course, sometimes the question doesn't make it obvious. You have to figure out that is the charges are moving. So whether it is positive or negative charges, as long as they start to flow or they start to move, then this formula comes into use. And normally they will either tell you the time taken to move, or you're supposed to find out the time, correct? Time of movement or time of flow, how they flow within, let's say 10 seconds or 1 second. So chances are you will make use of this formula. Okay, so putting that aside, the other thing that I want you guys to be very clear is this. This one shouldn't be a problem. there's something called electric force, or sometimes they call it electrostatic force. But I think for physics, this is not so commonly okay lah. I mean, it is still common enough. Now, get used to seeing this word as well, electrostatic force, electric force. Well, obviously they are forces. So as I said, it could be a repulsion or it could be an attraction. Now, I won't go through every single point about that unless you have questions, so I shall move on. But just take note of this word electrostatic force. It means the same thing. Now, we have also gone through what we call electric field. So I hope you still remember all the arrows and the lines, like all this. Okay, again, I won't be going through all these diagrams. You should have them in your notes. The long story short, direction is always from positive to negative. Look at the arrow. Positive to negative, positive to negative. Now, of course, in this case, you don't see any negative, but the same principle applies. Direction is still away, away, away from the positive. Now, I believe I stopped somewhere here about conductors and insulators. Okay, so of course, in this case, my conductor is referring to electrical conductor. All right, just like insulator is for electrical insulator. This is something that you may want to take note, even though it doesn't come out all the time. Okay, plastics. Of course, you guys may not be so familiar with what the different kinds of plastics, but in general, plastics tend to become negatively charged. You just may want to take down this point. I'm not saying that it's going to come up, may or may not. But let's also be a bit mindful. Let's say I have a plastic ball like this. It goes without saying, plastic is an insulator. Okay. So when I say that they tend to become negatively charged because they tend to pick up electrons, I'm often referring to the surface. Remember, plastic is an insulator. So the electrons are not able to go or move around within the plastics. Electrons cannot do that because plastic is an insulator. Therefore, more likely than not, electrons only stay on the surface. And even then, it's not on the whole surface, probably just the portion. Oh, by the way, how does a plastic and insulator pick up electrons? Well, I think I haven't mentioned this point yet, but essentially it's by rubbing. Okay, so you have a plastic object. If you rub on it with the correct material, let's say silk. Let's draw a piece of silk. So I rub a piece of silk over this plastic ball. Now, as I suppose you can deduce silk. You can't just use any material, it has to be the right material. So what happens is plastic will pick up electrons from the silk. So obviously the silk itself become positively charged because electrons from the silk has passed over to the plastic. Okay, so if you only rub on this surface, only this surface will become negatively charged and not the entire surface of your plastic ball. Okay, so yeah. So guys, that is how you make a plastic or an insulator electrically charged by rubbing. You cannot pass or send an electrical current into it. It doesn't work. Now, on the other hand, this is an insulator, as I said, plastic. If I have something else, I have a conductor. Okay, for you guys, obviously metals are conductors. So make sure you are very sensitive to this word. So if I have a metal ball, okay, there are two ways to charge it. So if I want to charge a conductor, there are two ways. One is you send a current into it. Or you link it to a current. Okay. Now, the other way is by induction. Now, induction, there is no contact. You notice for a current to work, the wire must be in contact. However, to highlight this word called induction, again, is 100% coming out. Alright, this concept of induction. So essentially what I do is I place another charged object. Let's say positive. Now, I do not care this object, whether it's insulator, whether it's conductor, does not matter. This object is charged. It does not touch. So there's no contact. Okay, so what happens is this. Because this is positive, it will induce, take note of the words that I use, induce a negatively charged surface on this side. So basically they are opposite. However, at the same time, this whole metal ball is a conductor, remember? So for this side to be negative, the opposite side becomes positive. Now, just be a bit mindful. Some of the teachers, in fact, most of them are quite fussy. You notice, what did I do? I wrote 7 negative on the right. So you should write the same number on the left. So try to be, in fact, not try, be equal. Now, the reason is this whole matter is electrically neutral, taken as a whole. So for one side to become negative, the other side must become positive and with the same magnitude. So just keep these few points in mind. Well, of course, guys, I hope you realize if I change this guy to, let's say, negative, this object, all right, there's no contact as always. If this is negative, then this side will be charged positive. Okay, and the other side, of course, becomes opposite, which is negative. Okay, so that's how it works. Just one last thing about induction. Okay, I repeat. If you ever use the word, oh, I am not done yet. If you ever use the word induction, it means that it's charging an object with a distant charge object. There is no contact between this conductor that you want to charge and the originally charged object. Now, one last thing, theoretically, because these two are opposite, I have positive here, I have negative there. So in theory, they actually experience an attractive electric force. Okay, so there is a force of attraction, but obviously it depends on how big or how massive these two objects are. Because if they are very, really big, then they may not move towards each other. Okay, questions? Anyone? No? Okay. All right, so let's see. Did I miss out anything? Induction. Okay, just one last thing. Okay, never mind. I'll just draw it straight there. Let's say, just one last thing about this. Again, I have a conductor. So if I have this guy here, which is positive, this side will become negative, opposite side become positive. You know what's the favorite question they like to ask? They say that they are going to join a wire, electrical wire, to this left side, and it goes to this thingy there. Right, come Jingxie, tell me what is this symbol?
Oh,
Good. So in this case, Jingxie, what will happen?
electrons move.
Move from where to where?
Ball, from ball to the ground.
Your ball right side or left side is positive, so there's a lack of electrons. Instead, electrons will move up.
Oh yeah.
Electrons are negative, so they will move up and try to neutralize this side. Okay, so don't be careless.
Okay.
Yep, Chloe, of course, take note as well. So basically, subsequently, the current will stop once this whole side has been neutralized. But don't forget, this side is still negative. Why? Because my charged object is still there. Right, so this left side of the ball is still negative, but the right side is no longer negative or no longer positive. So what I do next is I remove this wire. And I also remove this guy. You're only left with the ball. But charges, you notice, because the object is no longer there, these negative charges do not want to stay there anymore. So as a result, they will start to distribute themselves throughout the ball. Okay, so basically, now your charges are evenly distributed. I think I drew 5 right just now. So we'll just have 5. Okay, so they are now evenly distributed. So as a result, your metal ball is now negatively charged. It's no longer neutral. Okay, I think that about covers the common questions you will encounter. But I'll just emphasize on this word induction. Yeah, maybe later you take a look at it. It is the word that you want to use in your answers. Okay, questions, anyone? Okay, if not, guys, okay, one last thing, you will see this word. Oh, by the way, I've uploaded a copy of the worksheet in your Telegram, so please download it. You are likely to see this word. Test charge. Or sometimes they'll say point charge. So it means a very small charge floating in the air, perhaps. And over here, they say that it's positive, so it's positive. Now, what you need to remember is whether they call it test charge or point charge, these are movable. So this guy can actually move to the left, right, up, down, depending on the electric forces or other forces on it. So just keep this in mind. Test charge or point charge is just a very small charge which can be moved. Okay. Okay, guys, any questions, Chloe? I didn't hear from you. No? I think your microphone is off for some reason. If not, you can type in the chat box as well. Okay, anyway, as I said, download the worksheet from Telegram. It looks like this. So can you try to work out the questions? At least you only have 4 MCQs, by the way. Try out question 1 as well. But if you need my help, just voice out. But MCQs, I think they should be quite doable. Right, so yeah, go ahead. But of course, if anyone has questions along the way, yeah, voice out, please. Jingjie, are you done?
Almost.
Okay. Chloe, any questions? Better ask now.
Done.
Oh, okay, okay. Come, let's take a look. Come, Chloe, I didn't hear from you, so I hope you're still there. All right, of course, if you have any questions, do voice out or just stop me along the way. All right, so MCQs, I hope they are not a problem. Come, Jingjie, number one.
C.
Yep, so again, make sure it's always from positive to negative. Okay, should get it right, should get it right. Number two. Okay, so
Me
again,
again.
I think I emphasize you have to, I think I said this before, right? For your exam, typically you're either given 1 point charge or 2 point charges at most. So far, I've never seen 3 or 4 before. In fact, they should not give you 3 or 4. Okay, look at number 3. Number 3 is of course a bit tricky, but shouldn't be a big problem. Yeah, Jingjie, what do you put for number 3?
Put C eh.
C, yeah. Okay lah.
Eh,
Just notes. Make sure you realize that these arrows here, they are for electric field lines, direction of the electric field lines. Do not confuse with this. This one is really a force. So this arrow here is not an electric field line, right? So that's the only confusion some students actually have experienced. Okay, so let's go on. Now this is number 4. Jingjie, your answer?
B. B for boy.
Okay, good. Right, so yeah, like I say, you should get full marks for this MCQs. Okay, of course, any questions, please voice out. If not, I shall move on. Okay, just a note before I start on this structure questions. Now the scenario they paint here is quite realistic. For most of the time, for lightning to occur, the clouds have to be charged. And you can note this down, even though it's not very often asked as a question. Now, typically the clouds are negatively charged. And of course, it's not the whole cloud. Usually it's just the base surface, the lower surface of the cloud. So this is typically quite accurate. Okay, so anyway, if I look at the question, you do not even need to understand the cloud formation and stuff like that, because you are already given the current, you are given the time, so it shouldn't be a problem to figure out what formula to use. Some more, they even ask you for the charge. Right, so as I said just now, there is only one formula. So this is the one. If I manipulate it, it's the same as what I've written earlier. Okay, come, Jingjie, what's the answer you get?
1.21 C.
1.21. Okay.
Yeah.
That's a bit. Okay, can. Okay. I thought it's a bit small, but well, apparently that's how it is. Now, this is also quite a common question. Guys, I suppose if you observe around you, you probably can spot this not the copper strips, but this. Maybe you can see the copper strips too if you're observant enough. But probably this sharp point here, these are obviously your lightning rods. Probably can spot it around the top of the buildings. But anyway, what happens to the negatively charged particles in the copper? Guys, again, no surprise, copper is often used because, try to remember this, copper is a very good conductor of electricity. Of course, it's rather cheap as well. So that's why they use copper a lot in wires. Now, the other thing is, let me see, what was I going to tell you? This question mentions about negative charges or negatively charged particles. Make sure you understand that they are referring to electrons. Now, just to refresh your memory, if you still remember your chemistry, basically for matters, electrons are free moving, or at least the valence electrons are free moving. So that allows the metals to conduct electricity by the movement of the electrons. Okay, so anyway, what happens to these electrons? Yep, Jingjie, what do you write for this?
I wrote they move downwards.
Okay. Anything else?
No.
Well, it's a 2-mark question though, so you have to write a bit more than that. But of course, you will still get your 1 mark. Okay, come. First thing first, obviously, all these negative charges here are actually electrons. So you have all these electrons on the surface, bottom surface of the cloud. Now what happened is, but you do not need to use the word electrons in your answers, at least not for physics, at least not for this question. So what I can write is this. Now make sure you mention the negative charges which are given in the question itself. Now they want to see this word, repel. Oh, sorry, let me qualify in the cloud. So they repel the negative charges in the copper. So this is only then you mention. So the negative charges. I know it's a bit lengthy, but it's always good to be very clear in your answer. So the negative charges in copper flow towards. Now it's also good if you mention exactly where they move. I mean, you move downwards is fine, but no harm adding in what you're given. All right, in your question, they did use this plate and they also did use the word ground. Right, so I mean, just like primary school, try to make use of whatever info you're given and incorporate them into your answer. Okay, so yeah, that will help you get your 2 marks. Okay, questions, please ask. If not, I shall move on. Okay, let's see what's next. Chloe, I assume you are following. Otherwise, make sure you ask any queries. Okay, question 2 is a very, very standard question. I would say it's a typically difficult question. So make sure you know how to answer that. Now, likewise, they did mention negative charges. Again, by now you should realize these are referring to electrons. So again, make sure you understand what the question is asking. If not, you may want to voice out now. Why the metal foil moves away from the metal rock? This is so. Okay, Jingjie, so what's your answer for this?
Me,
Hmm?
I wrote the, what's it called? The electrons, right, from the plastic. They, how to say, they repel the ones in the metal rod, right? So
Yep.
it moves downwards.
Good.
Then it repel the electrons in the metal foil, then the metal foil moves away. Something like that.
Yeah. Something like that. Yeah, on the right track. Though, of course, no harm trying to make it clearer. So a few things. Now, I'll be writing in point form. So obviously, you should try to construct full sentences if you can. So basically, make sure you have the word repulsion. All right. So first thing first, the plastic, the charges, negative charges, repel. negative charges in metal rod. Okay, so next you have to mention, which also Jingjie mentioned already, negative charges move downwards. However, be very clear, they move down to this part, bottom of the rod. Okay, maybe I should draw them right inside the rod itself. But Jingjie, one thing you may want to include also, as well as the metal foil. So the metal foil will also receive some of the negative charges, or actually electrons. This part you really have to mention it. Now, perhaps not so important, but well, just to make sure you're clear about that. The top of the metal rod here is left with positive charges. Now, last part, you again use the word repulsion. All right, but in this case, let's be very clear. The negative D or negative order of the rod repels a negative metal foil. So that would nicely sum up your answer why the metal foil moves away from the metal bottom of the metal rod. Okay. Now, but of course, there's no need to write. However, make sure you realize why they even use the word foil. Foil means that it's a very light piece of metal, light and thin. And therefore, it is movable. Whereas, whereas the rod itself, you expect it to be thick, you expect it to be heavy, so therefore it remains stationary. Okay, otherwise they'll move away from each other, which doesn't happen in this case. In this case, only your metal foil is moving and not your metal rod. Okay, so this is the reason, even though you don't really need to write it down in your answer. Okay, any questions? Otherwise, I shall move on. Okay, no, fine, okay. Okay, this one isn't very difficult, but just keep this term in mind, insulating thread. Now, essentially, why they use this word is, all right, it means that it does not allow, or okay, let me rephrase it. It means that charges cannot move through the thread. Okay, so I mean, don't that is the implication of the word insulating thread. Okay, so anyway, back to here. I hope you guys have no problem with this. What can be deduced about rod Y? Not a very difficult question, I hope. Yep, Tingjie, what can you say about rod wide?
Arrow is positive.
Okay, yeah. But of course, it's the explanation part that takes a bit of effort. Now, first thing first, okay, again, I'm just going to write in point form. It's anyway 2 marks, so I won't spend too much points on it either. Right, first thing first, you have to mention that, let me see, these are conductors. Okay, so all these are conductors. Now, I mean, of course, there's no need to write this in your answer. However, this also implies charges can move through them. So first of all, from here, you have in your answer, this is your answer already. Some of the positive charges move to A. Okay, not all, obviously. Some positive charges are transferred from X to A. Now, personally, I would always want to mention the direction of movement, meaning from where to where, if you can. Okay, so obviously that makes X positively charged. Now, at the same time, likewise, charges from Y, I mean, some charges, unknown charges, of course, at this point. Okay, some charges are transferred okay, from Y to B. Uh-huh. So therefore, since A and B repel, B is positively charged too. Like A. Well, of course, the positively charged positive charges on B came from Y. So lastly, you can conclude that Y was positively charged. Okay, so again, maybe a bit excessive, but essentially make sure you use some of the keywords like transfer from where to where. Obviously, if you can, emphasize whether it's positive, negative, all right? And of course, repulsion. Yep, this is an important keyword. Repulsion, attraction, all these are important keywords. Okay, again, I won't further elaborate. Any question? Okay, this will be the last part, right? Now, it's also possible that they can ask you to define. This is actually a definition question. What is an electric field? Guys, no choice. You just have to remember the definition. It's based on the electric force on a charge. Okay. Okay, so simple as that. It's just a 1 mark question. However, try to get that 1 mark. Oh, by the way, this session is recorded as usual, but we put out this link to this recording in Telegram. So in case you need to look through it again, yeah, it's available. Okay, 4B. Yeah, you better get it. This is just straight from the textbook or straight from your notes. All right, make sure you draw all your lines nicely. Up to you, you can draw 6 or 8. All right, make sure the arrows are pointing towards it, towards the charge. Okay, so yeah, nothing to explain. Okay, last one. This one, you guys better get it right as well. On each field line to show the direction of the electric field. Okay, just a 1 mark question, huh? All right, yeah, you better get it. So I won't even ask you. I'll draw straight in. So arrows are always away from positive and towards negative, but there's no negative here. Just a small reminder, make sure all these lines have their arrows. Try not to miss out a single line. Okay, that would be a a loss of marks. Okay, question, anyone? No, Jingqie, fine. Chloe, can I assume that you're fine too? Yep. So, yep, I think that about covers it. Of course, I didn't show you any of the more difficult questions. Maybe if there's time, I'll show them to you this coming weekend. Right. So, yeah, I think that's about it for today. If there are no final questions, then I shall end the session here. All right. So I'll see you this weekend. Okay. Bye.